Hello and welcome to your stats video. All right, so this is our chance to practice the main types of open-ended problems that you're going to see in this unit. All right, so what does that mean? It means creating a bunch of different confidence intervals, and it means calculating a bunch of different sample sizes. All right, so let's dig in and see what we've got here. So a simple random sample of 1,100 males aged 12 to 17 were asked whether they play big online role-playing games. 775 said they did. Use this information to construct a 95% confidence interval to estimate the true proportion that play these games. All right, so because we're trying to estimate a proportion, we're going to be using one prop z interval. All right. And this generally asks for x, which is your number of successes. It asks for n, which is your sample size, and it wants to know what you're using as your confidence level. So our x would be this 775. Our n would be our sample size, so the 1,100. And then the problem tells us that we're doing a 95% confidence interval, so we would put a 0.95 in there. All right. Now, if we go to the calculator, all right, that is the stat tests window. All right, we're going to skip all the tests. We're going to go down to the interval section, and there's our one proportion z interval. All right, so 775 said they played, 1,100 was our sample, and we're doing a confidence level of 95%. All right, so that gives us a range of 0.67758 to 0.73151. All right. And then if we were going to write a little sentence, we would just say we are 95% confident the true proportion is between, we'll round this a little bit. So 67.8% and 73.2%. All right. Now, this right here is your point estimate, or it's your sample result. So this 0.7045 is the 775 divided by 1,100. So that's what we got in our sample, but we have to kind of give us a little leeway above and below. So there's our interval. All right. And that interval is based on the standard deviation. It's based on the sample size. It's based on all of those things to kind of come up with this interval that says, all right, if we repeat this process, 95% of the time, our interval will contain the true value. All right, next, suppose you wanted to estimate the proportion with 99% confidence to within 2%. How large of a sample would you need? All right, so this is looking at our margin of error formula, which says margin of error equals z star times PQ over N. All right. Now, on this one, all right, where are we? Oh, 99% confidence is what we're going to use to figure out our Z star. All right. This 2% is our margin of error. Now, this one doesn't give us any starting values for P and Q. So worst case scenario is that P equals 0.5 and Q equals 0.5. All right, so that's sort of our worst case scenario. When they don't give us any baselines, we use 0.5 and 0.5 for P and Q. If they give us a baseline, we use that, but this one doesn't give us anything, so we just use 0.5 and 0.5. Now, as far as getting the Z star here, all right, well, let's actually start filling things in. So margin of error is 2%. Z star is going to require us to do an inverse norm. All right, now if we're doing 99%, that means there's 1% left over, but that 1% gets divided between the left and the right side. So we're actually going to do an inverse norm of 0.005. 0.005. We've got the square root of 0.5 times 0.5. And we're going to divide by n, which is what we're solving for here. All right, so inverse norm of 0.005. 2.58. Again, ignore the negative. So we're left with 0.02 equals 2.58. And then I'm just going to rewrite this as two separate radicals. So 0.5 times 0.5 divided by the square root of n. All right. Multiply both sides by the square root of n. I get 0.02 square root of n equals 2.58 times the square root of 0.5 times 0.5. And then at this point, I usually just go and do the rest of it on my calculator. So the square root of 0.5 times 0.5 is just going to be 0.5 because you're squaring 0.5 and then taking the square root. Multiply that by 2.58. Okay, 1.29, divide that by 0.02, 64.5, and then square that to get rid of the radical. And I end up with 4160.25. So n equals 4160.25. But we always want to make sure that we're not over 2%. So even though this is technically would round down, we always round up in these problems. So we would say 4,161 people is what we need if we want to be within 2% and have 99% confidence. All right. A recent poll found that 433 out of 1,548 randomly selected adults questioned felt that unemployment compensation should be extended an additional 6 months while the country is in its current economic downturn. We want to use this information to construct a 90% confidence interval to estimate the proportion of U.S. adults who feel this way. Okay, so we're still estimating a proportion. So we're still using one prop z interval, which means we still need an x, and the problem gives us that as 433. We still need an n. The problem gives us that as 1548. And this time our confidence level is only 90%. All right, so once I have those numbers, I can go back to stat tests, go down to the interval section, and I'm picking one prop z interval. So 433, 1548, 90%. Calculate that out, and then I get my interval. Again, p hat is the sample result. That's the 433 out of 1548. The interval is the 0.26095 to 0.29848. And then if we were going to write a little sentence, it would be, we are 90% confident the true proportion for the whole population is between, again, I'm going to round these, 26.1% and 29.8%. All right, now suppose you want to estimate the proportion of people that feel unemployment compensation should be continued with 80% confidence within 1.5%. Calculate how large a sample you would need. All right, so again, going right back to that formula we just used, m equals z star, square root of pq over n. They're still not giving us a baseline p or q. So we're going to use p equals 0.5. We're going to use q equals 0.5. And then we're going to go through and use this to figure out our z star. And then the problem gives us the margin of error that we're calculating for. All right. So 1.5% would be 0.015. Z star of 80% means that we've got 20% left over, but that 20% gets split between the left and the right. So 0.10. And then again, we're using worst case scenario, so 0.5 times 0.5 over n. All right, so inverse norm, 0.10. All right, we get 1.28 because we ignore the negative. So 0.015 equals 1.28 times the square root of 0.5 times 0.5 over the square root of n. All right, multiply both sides by the square root of n, and then I usually do the rest of it from that point in my calculator. All right. So we already talked about this, but 0.5 times 0.5 is obviously going to be 0.5 when we take the square root times the 1.28 divided by 0.015, and then we square both of those, and we end up with n equals 1820.44. Again, we always round up with these no matter what the decimal is. I mean, if it works out to be an exact number, we don't have to round it up. But in this case, we'd round it up. So 1,821 people to make sure that we are no more than 1.5%. Because technically, if we did 1820, we'd be a little above 1.5%. All right. So these are the types of problems you need to be able to do with proportions. Figure out a confidence interval, figure out a sample size. The back deals with means. All right, so this is same premise, but now instead of confidence intervals, instead of proportions, we're doing means. So you want to estimate the mean field efficiency of a Ford Focus with 99% confidence and a margin of error no more than 1 mile per gallon. Preliminary data suggests that the population standard deviation is 2.4. How large of a sample do you need? So we're still doing margin of error equals Z star. It's just now we're no longer using P and Q. We're using population standard deviation divided by the square root of n. So only part that changes is this right here. All right. They tell us the margin of error is no more than 1 mile per gallon. So we're going to use 1 as our margin of error. They tell us that our standard deviation is 2.4, and we're going to use this 90% confidence to find our Z star. All right, so we get 1 equals 99% confidence. We actually just did one like this on the front, but that means there's 1% left over. Split between the left and the right is 0.5%. So that's going to be 2.58. The problem tells us the standard deviation is 2.4, and then we have to solve for the square root of n. All right, so multiply both sides by the square root of n. You just end up with the square root of n equals 2.58 times 2.4. I mean, technically it's 1 times the square root of n, but 1 times anything is just itself. So 2.58 times 2.4. All right, no reason to divide by 1 because it's not going to change it. So just square it, and we get n equals 38.34, or n equals, or let's just say 39 people. All right, so again, we keep rounding up here to make sure that we're not over 1 as our margin of error. So 39 people in total. Always round up. All right, so same type of problem, just this piece changes, and if anything, it just makes the equation a little easier to solve. All right, National Fuel Saver Corporation manufactures the Platinum Gas Saver, a device they claim may increase gas mileage by 30%. They recently tested 15 identical randomly selected vehicles for percent change in gas usage. The sample mean is 29.43. The sample standard deviation is 16.23. Construct and interpret a 90% confidence interval to estimate the mean change in gas mileage. All right. Now, technically, we don't have enough information because our sample size is under 30. So we can't trust that the central limit theorem is going to give us a normal distribution because our sample size is too small. So technically, this problem should tell us that that it follows a normal distribution, because otherwise our sample size is too small. But we're not going to worry about that right now. This isn't a question about the conditions. It's just telling us to calculate a confidence interval. So that's what we're going to do. Now, when we're doing means, we always use T interval. All right. And this is the thing that kids goof up the most. But they want to pick Z interval because when we're doing proportions, it's one proportion Z interval. So they're like, oh, Z interval, that's what I want to use. Z interval is if you know the population standard deviation, and we never know that. So literally, I will never give you a problem that requires you to use Z interval. It's really more of like a theoretical thing than something that gets used in practice a lot. So we're going to go to T interval. We're going to put in the stats because we don't have data this time. All right. So we need to know X bar, which the problem gives us as 29.34 or 0.43, sorry. We need to know sample standard deviation, which the problem gives us as 16.23. We need to know our sample size, which the problem tells us is 15. And we need to know our confidence level, and they're looking for a 90% confidence level. All right. So there's the 4 pieces of information we need from the problem: sample standard deviation, sample mean, sample size, confidence level. All right. Once we put all those in, 29.43, 16.23, sample size of 15, confidence level of 90%. All right. We can use all of that. Hit enter. We'll get our confidence interval, which is 22.049 to 36.811. And if we were going to write a sentence about that, we would say like, all right, we are 90% confident the true mean is between, let's say, 22.049 and 36.811 miles per gallon, I think is what we're measuring here, right? Yeah, miles per gallon. Wait a second. I don't think we're measuring miles per gallon. Device that claims may increase gas mileage by 30%. I think we're just doing like percent increase. So this is probably just, between 22.049 and 36.81% increase. All right, so we don't know exactly what it is, but we think that it's somewhere in that range based on our sample results, based on this confidence level, based on the size of our sample. All right, so main thing here is just please do not pick Z interval. As many times as I warn kids, somebody always does it, but please do not pick Z interval, pick T interval. All right, you want to estimate the mean amount spent by customers at a local gas station with 98% confidence and a margin of error of no more than $2. Preliminary data suggests the standard deviation is 5.1. How large of a sample do you need? So again, it's just another one of these problems right up here. So margin of error equals Z star, standard deviation divided by the square root of n. All right, it tells us the margin of error is no more than $2. So we're going to use 2 as our margin of error. It tells us that we're doing a 98% confidence. So we're going to do this to figure out our Z star, specifically inverse norm of 0.01, because there's 2% left over and we're splitting it between the left and the right. And then we can plug in our 5.1 as the standard deviation. All right, so distribution inverse norm of 0.01 is 2.33. So 2 equals 2.33. 5.1 divided by the square root of n. Multiply both sides by the square root of n. And then at this point, I usually just do it all on my calculator. So 2.33 times 5.1 divided by 2. And then I'm going to have to square that. And I get an n of 35.3, which means in total, I really need to talk to 36 people if I want to be within $2 as my margin of error. Okay, last problem. Considerable research is being done in bioremediation, the use of living organisms to clean up pollution. In a recently conducted experiment, researchers used fungi to degrade hydrocarbons, the byproducts of incomplete combustion of fossil fuels. These byproducts can cause cancer, and their accumulation in water and soil poses an environmental hazard. In order to be cost-effective, a minimum of 1.00 microns grams of soil of a particular hydrocarbon must be degraded. The researchers added fungi and growth media, essentially sugar, to the soil in 9 containers with random samples of soil and obtained a mean of 1.076 and a sample standard deviation of 0.158. Find an 85% confidence interval for this result. So this is nice background information up at the top here, in case you're curious about this sort of thing. But really, what we need to focus on to figure out this problem is the sample mean, the sample standard deviation, the confidence interval, and the sample size. Now again, our sample size is pretty small here, so technically we should have been told that we were dealing with a normal distribution, but we'll continue on just the same. So t interval, all right, we're going to put in the different stats. X bar the problem gives us is 1.076. Standard deviation the problem gives us is 0.158. Sample size is 9. And our confidence level is 85%. Okay, so again, we go to stat tests. We do not use z-interval, we use t-interval. All right, we type in 1.076. We type in 0.158. We type in a sample size of 9. And we change our confidence level to 85%. All right, and when we do all of that, we are going to get an interval from 0.99214 to 1.1599. All right, so we can say we are 85% confident. The true mean is between 0.99214 and 1.1599. All right, so we're right at the threshold of cost effectiveness. In fact, we might end up even being a little below because we can't rule out the fact that the true average might be below 1. So it's kind of a toss-up here of, all right, we need to at least have this to be cost effective, and we're sort of right on that edge, and our interval doesn't give us total confidence that we'll actually be above that 1.0. All right, so these are the main types of open-ended problems. As long as you can do these types of problems, t intervals, sample sizes, one prop z intervals, sample sizes, you should be good for any open-ended questions that are going to show up in this unit. All right, That is all I've got. If you have any questions, let me know, and we'll go from there. Have a great day.